Darling, get ready to be on the edge of your seat because I had the most bone-chilling nightmare last night. Picture this, we were trapped amidst the relentless COVID pandemic, battling the deadly virus, but that was only the beginning. As if things couldn't get worse, the scorching heat waves caused by global warming were claiming lives left and right. And just when it seemed like it couldn't get any darker, a colossal asteroid came hurtling towards Earth, obliterating everything in its path.
Calm down, Currio. It was just a nightmare. The COVID pandemic is over. Many scientists all around the world are currently tirelessly working to solve global warming and climate issues, and there's almost a 0% chance of any asteroids destroying Earth.
Almost zero. There is still a chance. Humans are the most superior species to ever exist. Look at how far we have come. I was created. We can't let global warming, pandemics, or even asteroids eliminate all the hard work humans have done. I just wish there was another habitable place that could be like a safety net for humanity.
Look at you, Currio, with such great ideas. In fact, scientists and engineers such as Dr. Chris McKay, Dr. Jim Casting, and Elon Musk are all currently working on creating another habitable planet for humans, specifically terraforming Mars.
Terraforming Mars? How?
Although terraforming Mars cannot be done with the current available technology, I believe with the current advancements in technology, Mars will be habitable in the near future. Let me further explain. Terraforming Mars involves a complex process that encompasses three significant interconnected transformations, building up the magnetosphere, atmosphere, and raising its temperature.
Building up the atmosphere? How is that possible?
One method involves introducing ammonia, or NH3, which is expected to exist in significant quantities in frozen form on minor planets orbiting the outer solar system. One possibility is redirecting the orbits of these ammonia-rich objects to collide with Mars, transferring the ammonia into the Martian atmosphere. But
oh no, there is a but.
Ammonia is unstable in the Martian atmosphere and breaks into nitrogen and hydrogen within a few hours. As a result, while ammonia is a potent greenhouse gas, its ability to generate substantial planetary warming is limited. Over time, the nitrogen gas would likely be depleted through processes similar to those that stripped Mars of its original atmosphere. But these processes are believed to have taken hundreds and millions of years.
Well, it looks like that method is out of the window now. Any other possibilities?
Another method to generate a Martian atmosphere involves importing methane or other hydrocarbons. Releasing methane into the Martian atmosphere could contribute to the greenhouse gas effect. But
seriously? Another but?
Similar to ammonia, methane is a relatively light gas and even less dense than ammonia. Consequently, if introduced, methane would also be lost into space and at an even faster rate than ammonia. Even if the method were devised to prevent its escape, methane can only persist in the Martian atmosphere for a limited duration before it gets destroyed.
I'm starting to lose hope here. Have scientists thought of any ways to raise the temperature of Mars?
Well, there have been suggestions to utilize strong greenhouse gases like sulfur hexafluoride, chlorofluorocarbons, or perfluorocarbons to warm Mars initially and maintain long-term climate stability. These gases are proposed because they generate 1,000 times stronger greenhouse gas effect than carbon dioxide. Estimates indicate that approximately 0.3 microbars of CFCs would be required to sublimate the south polar carbon dioxide glaciers on Mars, equivalent to about 39 million tons of CFCs. According to estimates, a terraformed atmosphere with Earth-like pressure and composition could sustain a 70 Kelvin greenhouse effect, with an annual emission of 170 kilotons of specific greenhouse compounds.
That's incredible. But how are scientists planning to get all these greenhouse gases?
Typically, proposals envision producing these gases on Mars using locally extracted minerals, nuclear power, and a substantial industrial effort. The potential for mining fluorine-containing minerals to obtain the necessary raw materials for CFCs and PFCs is supported by mineralogical surveys of Mars, which suggests the presence of fluorine in the planet's bulk composition at approximately 32 parts per million by mass, compared to 90.4 parts per million for Earth. Alternatively, CFCs could be introduced by sending rockets, loaded with compressed CFCs on collision courses with Mars. Upon impact, the rockets would release their payloads into the atmosphere. This approach would require a sustained barrage of these CFC rockets for slightly over a decade, while Mars undergoes chemical changes and becomes warmer.
I'm feeling much more at peace. But I must say, hearing all the methods to how Mars could possibly be habitable one day is so interesting.
That's great to hear. I agree. It's truly fascinating to think about how our understanding of Mars is just beginning to unfold. And I'm so excited to see what the future holds for humanity.
I can't wait to see that too. Thank you, darling, for your sharing on this incredible knowledge about terraforming Mars today. I think we are all inspired. Now is the time for us to say goodbye. Thank you everyone for watching. See you in our next episode. Bye bye!